Good morning. Thank you for joining us today here at the Vancouver Aquarium Marine Science Center and those of you online. Just one quick bit of housekeeping for those of you who are watching online. If you wish to ask questions of the speakers here today, you can either comment under the YouTube live stream, and we'll look for those comments and direct them to the appropriate speaker, or you can tweet us at VanAqua using the hashtag KWResearch. And we'll be monitoring both of those. We'll do our best to relay those questions. This morning we'll be hearing from Dr. Lance Barrett-Lennard, head of the Vancouver Aquarium Marine Mammal Research Program, from Dr. John Durban and Dr. Holly Fehrenbach, who are both biologists with NOAA's Southwest Fisheries Science Center, and with Lynn Berry, who is the branch chief for protected resources with NOAA Fisheries. She'll be joining us from Seattle. Lance will make some comments, then there's going to be a brief presentation that explains the project, and then there will be a Q&A with all four scientists. And afterwards, for those of you who are here on site, I'm happy to set up one-on-one interviews with Lance outside the theater. So without further ado, here is Dr. Lance Barrett-Lennard.
Thank you, Dina. Thanks for coming, those of you who are present in flesh and blood, and those of you who are here virtually. It's a bit spooky for me, but glad you're here. Those of us who live in this corner of the world, northern Washington State and southern British Columbia, live in a land of treasures. We have beautiful mountains, fertile valleys, expansive forests, major rivers, diverse and complex shorelines, and at the base of it all, an island-studded coastline, boiling with life. The purity of that ocean, of course, is compromised in many ways by the activities of humans. And as marine biologists, we struggle with identifying and measuring those impacts. One of the best indicators of the health of an ecosystem generally is the presence of an abundance of large predators. As impressive as they are, in this case, of course, the predator that we're primarily focusing on is the killer whale. As impressive as they are, their existence depends on intact marine food chains from plankton on up. They're great indicators. Killer whales are highly intelligent. They're as long-lived as humans. They're fiercely attached to their offspring and their kin. They're embedded in the lore and culture of First Nations, and they're objects of fascination by locals and visitors to this area alike. The species is really one of our treasures. Sadly, killer whales in this beautiful corner of the world are struggling. The so-called southern resident population that you'll hear more about shortly, that spends most of its time in southern BC and northern Washington State, numbers only 82 or 81 individuals, depending on how you do the accounting, far fewer than in the recent past. Southern residents and their immediate neighbors, the so-called northern resident killer whales, I apologize for these unoriginal names, are fish eaters, and they rely primarily on Chinook salmon. We don't entirely understand why they're so dependent on that particular species, but the fact is that it's very clear that they are. Chinook salmon, of course, are the largest but least abundant of the local salmon species. 10 years ago, my friend and colleague, Dr. John Ford of Fisheries and Oceans Canada, showed that the mortality of resident killer whales is strongly linked to the abundance of Chinook salmon. So in poor salmon years, resident killer whales die in greater numbers, and their reproduction declines as well than in years in which salmon is abundant. So there's a bit of a time lag there, but it's very clear that there's a strong dependence of the killer whales on this particular species of salmon. Armed with this knowledge, the U.S. National Marine Fisheries Service and our Department of Fisheries and Oceans embarked on a series of workshops to examine the impact of fisheries, of human fisheries on salmon, on Chinook salmon in particular, on both northern or on southern resident killer whales in particular. They hoped to come up with clear recommendations for minimizing the impact of, it was hoped that clear recommendations for minimizing the impact of these fisheries on salmon, on killer whales would emerge, but those recommendations proved elusive. Furthermore, it was clear that counting dead whales was not going to help us understand the relative importance, the fine details, the relative importance of different salmon runs and the impacts of specific fisheries anytime soon. Prior to the salmon orca workshops, my partners on this project, John Durban and Holly Fehrenbach, had pioneered a method of measuring the size and length and width and the shape of killer whales from overhead photographs taken from a helicopter. This approach, known as photogrammetry, offered the prospect and the promise of detecting sublethal impacts of prey shortages on resident killer whales, which was a great improvement on a reliance on body counts alone. John and Holly and I had studied killer whales together in Western Alaska for many years and decided to collaborate on a study using a small, unmanned, remotely controlled hexacopter to obtain photogrammetry images of northern and southern resident killer whales with the objective of measuring growth rates, pregnancy rates, and of most interest in a conservation context, I think, changes in body condition in relation to changes in the abundance of salmon. And you have to understand, of course, that salmon populations fluctuate considerably year to year. We began the project in 2014 in Johnson Strait off the northeast coast of Vancouver Island. The hexacopter we used was purpose-built by NOAA and provided to us for the project, and it worked beautifulully. It was very stable, reliable, quiet. We operated it at an average altitude of 100 feet, well above the whales. We watched carefully during the study, during the first year in particular, but again in 2015, for indications that the whales were disturbed by the hexacopter, or even noticed it. And we found no indication of either. It seems like a very non-invasive research tool. The images the camera suspended from this hexacopter captured were perfect for our purposes, as you'll see. Our focus in the Johnson Strait area was on northern resident killer whales, members of the northern resident killer whale population, about 280 animals. In 2015, this past summer, we returned to Johnson Strait to obtain comparative images of northern resident killer whales. And we also expanded the study to include the endangered southern resident killer whale population, this very small population that spends much of its time along the Canada-US border. Both efforts were successful by all measures. We obtained photogrammetric images of all 81 to 82 members of the southern resident population and of a similar number of northern residents, providing an excellent baseline of measurements to detect change in the future. For the study to be really successful, however, it'll have to continue over several years, because really what we're interested in here is looking at change over time that we can attribute to environmental factors. Finally, given the plethora of unfavorable stories in the past year about drones, I'd be remiss if I failed to mention that yes, we are fully permitted in both Canada and the US. Specifically, we have permits from NOAA and Fisheries and Oceans Canada to work above and near killer whales, and we have permits from the FAA in the United States and Transport Canada in Canada for our hexacopter operations. We often say that the combined weight of our permits exceeds the weight of the hexacopter. I don't know if we've ever actually tested that. If it's not true, it's close to it. So that's enough background. I'll move on now to a podcast produced and kindly provided for this purpose by NOAA, after which, as Dina mentioned, Holly, John, and I, and our colleague Lynn Barry, who is, by the way, the recovery coordinator on the US side for southern resident killer whales and a champion of this project, will join me in taking your questions. Thank you.
There's a population of killer whales that spends part of the year around the San Juan Islands north of Seattle. They're called the southern resident killer whales, and they're very endangered. There are only 81 of them left in the wild. That's the bad news, but the good news is that 81 is 5 more than there were last year. There was a baby boom among the southern residents recently that added 5 to their number, and for a population of this size, 5 new individuals is a very big deal. Today we're going to look at some amazing photographs that will give us a glimpse not only of some of the new calves, but also of the family lives of these whales. The photos were taken with an unmanned aerial vehicle, and to help us understand the photos, we have one of the scientists who took them here with us today. John Durban is a marine mammal biologist with NOAA Fisheries, and he recently got back from the research expedition that yielded these incredible pictures. John, thanks for taking my call.
Oh, no problem, Rich. Just happy to talk to you.
So you recently returned from several weeks of field work where you and your colleagues were using an unmanned aerial vehicle to photograph killer whales from above. I'm told that you were photographing the southern residents and also the northern residents that live across the border in Canada. What were you trying to accomplish?
Well, we're really answering a very simple question. Are these killer whales getting enough to eat? Both these populations of killer whales are specialists in preying on salmon, and particularly Chinook salmon. And several stocks of Chinook salmon are themselves endangered, which makes these whales vulnerable because there's concern about their prey supply. Are they getting enough to eat? So what we're trying to do with the hexacopter is simply to get a camera above the whales and measure their length so we can monitor growth, and to look at their width profile so we can see how fat they are. And we do that by taking pictures and taking measurements from the pictures.
Gotcha. So you can get very precise measurements from these pictures, is that right?
We can. Our small hexacopter has an onboard pressure altimeter, so with every photograph we get a measure of altitude, so we can scale from measurements in pixels on the photograph to measurements in centimeters on the scale of the whale. And from 100 feet up, we're typically accurate to just a few centimeters, so we can get very precise measurements.
I want to mention that you and your NOAA colleagues took these pictures with our research partners at the Vancouver Aquarium. So what I'd like to do is to take a look at some of these pictures, and maybe you could tell me what you see in them. That sound okay?
Sure, that sounds fun.
Okay, great. So the first photo I have here has two whales in the frame. They look like they're speeding along in tandem. What's going on here?
Yeah, they do. And what it shows are two adult females. The whale on the top is L47, a female who's 40 years old, or just a little over 40. The whale below her is her adult offspring, L91, who now is about 20 years old. They're traveling together, which isn't unusual in killer whale society. The offspring often stay with their mothers for their whole lives. But what's interesting about these two whales is their difference in shape. You can see that L91, the whale at the bottom, is really quite fat. So if you look around the dorsal fin, or a good marker is that grey saddle patch around the dorsal fin, you can see she's really wide there, and very wide in comparison to her mother. If you look above her around the saddle patch, the mother's quite lean there. And that's because we think L91 was heavily pregnant at this time. We didn't actually notice it at the time because we didn't have much time to review the pictures, but just 5 days later we had cause to go back and have a look, because this whale, L91, was seen with a brand new calf just a few days later.
Cool. I think actually I have a photo of that. So another photo I have here is of a whale. I think you're going to tell me it's L91, and a calf swimming just on her right.
That's right. This is L91, now not looking quite as fat. You look at that saddle patch, she looks more like a normal killer whale. And the reason is she's given birth to this tiny little guy, the newest member of the southern resident population, L122. So we're within a few days of the birth of this calf. And this is the smallest calf we've ever photographed from the air. I think what I love about the picture is the kind of nurturing you see here, that calf is swimming up by its mother's head. In fact, the white on the side of the mother's head, that's her eye patches, so it shows you her eyes just in the front of those. So the calf's up by its eye, she's keeping an eye on it. It just shows the kind of level of care and close nurturing that's going to go on, and really persists throughout this calf's life. Its mum is its ticket to growing and making it, and it's great to see this close bond in the early days of life.
Great. And then the next picture I have is also of an adult, and I believe it's the same calf. And they're no longer moving forward together. They're kind of looking at each other. What's going on here?
Yeah, you can see here that L91 now has something in her mouth, and actually that's a big part of a salmon. You can see some of the fish is actually beneath her and sinking. What we were able to see as we were flying the hexacopter is that two of the members of this family group actually came over towards the mother and brought a salmon to her. They dropped it and she picked it up. And I think it's a great example of how the whole family are involved in rearing this calf. Because L91 is now nursing the calf. That's very energetically costly to produce this energy-rich milk. And particularly in the early days of the calf's life, she probably doesn't have much time to dive down and collect fish on her own. So we can see these related family members are helping feed the mother and therefore helping to raise the calf. And I think it's a great example of how society and group living is really important to these whales. They do family better than we do. They stay in their family their whole lives, and they'll help care for this newest member of the family. It's a great reminder of that.
Speaking of newest members of the family, here's another picture of a mother and calf, a different pair this time. This picture's super clear.
Another beautiful picture. This is J16, the mum, with one of the calves born this year, just swimming over her back there. And it's just a great example of the kind of nurturing and close care that goes on between a mother and a calf. And this is a a great photogrammetry image because we can really see the edges of the whales, and you can see the resolution we get of the calf. We'll be able to monitor this calf's growth in years to come and make sure it's getting enough food.
The next picture I want to talk about is a great one. It's actually my favorite one. I see a picture of a killer whale, and there is a youngster coming up behind her to nurse. Tell me about this picture.
Yeah, this is a stunning picture. The female here is L94. She's a 20-year-old female, and this is another of the calves that was born over this last year. And the calf is nursing. It's getting milk from the female's mammary slits, and it'll nurse in that way for a year or two, probably up to 2 years, after which time it'll start to take solid food, but still be largely fed by its mother and helped in feeding by its mother. It's a great image.
Yeah, I love it in part because it's just a beautiful, graceful image. But also, I've never seen a picture like this. I've seen pictures of killer whales nursing in captivity. I've never seen a picture of this happening in the wild. Is this the first time you witnessed this?
It certainly is the first time we've seen it with this clarity. Previous attempts to photograph from the air, we've been in manned aircraft like helicopters, so we've been a lot higher, so we're not getting this kind of detail. So this is the first time we've seen this kind of behavior and this kind of clarity.
Great. This is the second year you photographed these whales from a hexacopter. In fact, we had a conversation much like this one just about a year ago, and I've got here one of the pictures you took last year. I guess it's from the northern residents, so this is the group that lives up to the north. Tell me a bit about these guys, and tell me about the picture you got of them this year.
Yeah, this is one of the stunning pictures we obtained last year. In fact, one of the first pictures we ever obtained of killer whales with the hexacopter, and we were blown away by the quality of it. So this shows the I-16 matriline of northern resident killer whales. And if we look closely in the middle of there, we see a small little grey calf. That's I-144 that was a young of the year last year, and he's swimming just below his mother, so the whale above him is I-51. And the whale above her is its sibling. That's I-129 that was 5 years old. This year we were able to photograph the same group. So if we look at the picture we obtained from this year, now we're just looking at 3 whales. At the bottom is the mother, I-51. In the middle, that's the new little calf from last year, I-144, and above is its older sibling. And we can see it now looks like a normal killer whale. The calf is no longer small and mottled. This shows our ability to monitor growth 1 year to the next. We'll take these measurements and use our altitude and our focal length and convert them into real quantitative measurements to see how that growth compares to other calves. And to me, it's a great graphic example of what we're trying to do with this photogrammetry, of monitoring both shape change and growth over the long term.
This year we've looked at a bunch of photos of killer whales that are in relatively good shape. Their bodies are robust. They don't seem undernourished, as some of them did last year. There were also a number of newborns in the southern resident group this year. So the population seems to have had a good year. I know that part of the reason you're doing this research is to correlate their condition with salmon runs. So salmon is the main food. I suppose the hypothesis might be that if there are large salmon returns in a given year, they have a lot to eat, perhaps they're doing better. Are you able to make any conclusions as to why the whales seem to be doing well this year?
Well, yeah, I think it's a bit too early to make conclusions just because we've only got a couple of years for comparison. But in the long term, that's exactly what we want to do, is to compare year in, year out how the whales are doing compared to the salmon returns. And even we want to go beyond that and look at this seasonally, how they're doing in the spring compared to the fall. I think it's fair to say that this year we saw a lot more robust whales than last year, and you're right, the southern resident killer whales have had a number of new calves, in fact 5 over the last 12 months or so. So I think it is a sign that feeding's been okay for them and pretty good in the last few months. But future monitoring is going to tell us whether those calves survive and grow to recruit to the adult population. So I think the success of our study will be measured in longevity, whether we can keep this going to track growth and changes in condition and changes in reproduction, and see if we can link it to not only salmon returns, but specific runs of salmon or times of the year when that salmon are important. And by doing that, we can help to guide management actions to perhaps help enable these whales in lean times to make sure they get an adequate food supply.
Yeah. So, John, listen, I know you're really busy, so forgive me for taking up so much of your time, but I want to thank you for taking the time to talk with us. I think these pictures are really beautiful, and I think that people are going to enjoy seeing them, so thank you.
Thanks, Rich. It's really exciting to not only be part of taking the pictures, but to help talk about them too.
That was NOAA fisheries biologist John Durban. John asked me to make sure to tell you that they keep the hexacopter at least 90 feet above the whales at all times, high enough that the vehicle doesn't disturb the animals, and also to tell you that they have permits both from NOAA Fisheries to fly the hexacopter near these animals, which are protected, and from the FAA for flight clearance. I had a similar conversation with John following the first expedition to photograph killer whales last year. A number of the whales appeared undernourished last year, so that conversation was a little less optimistic, but it was really interesting. So if you haven't listened to that yet, you can find a link on our podcast page. That's www.fisheries.noaa.gov/podcasts. If you go there, you'll also be able to download the photographs we just spoke about. And there's a link to guidelines from NOAA Fisheries about how to use UAVs responsibly to view marine wildlife. If this is something you're going to do, please read these guidelines first. Thanks for listening. Join us again next time for more stories about ocean life and ocean science. I'm Rich Press, and you're listening to On the Line.
You have been listening to the NOAA Fisheries Podcast, On the Line. Join us next time for a first-hand look at the people and the science behind managing our nation's fisheries. For more information, visit NOAA Fisheries at www.fisheries.noaa.gov.
Okay, well, thank you very much. And I guess we're ready to go into the Q&A part of the session. We have John and Holly and Lynn all standing by, and it'll be a technological miracle if we all manage to communicate, but let's give it a try.
Get some of what John did in that video describing some of these incredible photos. Can he do that for us now on that screen so we have that? Can you describe some of the incredible photos, especially the ones with the mothers and the babies?
Did you hear that question, John?
I did hear that. Can you repeat the question for us, Lance?
Can I get you to describe some of your favorite, most remarkable photos that you took, especially the ones of the mothers and the babies, just so we have you describing them not just in audio, but also that we can see your face for the story? Tell me some of the favorite photos.
Absolutely. I mean, maybe I'll start by talking about the one of the calf nursing, because, you know, it's an incredible photograph, you know, because it's just a view we don't get when you're in a boat and when you're not close to the whales. But I think that it's the meaning behind that nursing photo that's so valuable, and that's that, you know, reproduction is costly for these females. They're going to have to, you know, not only catch fish for themselves, but feed the calf energy-rich milk. And so that process of successfully rearing a calf so it contributes to population growth and recovery is costly, and they're going to need adequate food in order to do that. So what our study, I think it's a great example of what our study is trying to do, which is monitor both the growth of the calves and the condition of the mothers, not only this year, but in future years and future seasons, so we can make sure they're getting an adequate food supply. So I think that picture is a real standout for us. The other photographs, and we've got photographs of L91 with a calf and J16 with a calf in the southern residence, and I51 in the northern residence. You know, those photographs are so valuable because I think it shows us that we've got new cohorts of animals in these populations now that we'll be monitoring for the coming years. So just to go back to Lance's introductory statement, you know, by being able to monitor growth and condition of animals is a lot more powerful than just monitoring births and deaths. For example, we're able to get data points on how fat they are and how long they are every time we photograph them, rather than just waiting to see when they die and how many animals die every year. So there's so much information in all those images that it's just you know, it's hard to convey it just by looking at the image, but you know, these images will persist and provide an archive and a reference point for the next several years.
Could you tell us more about the actual drone? There was mention of a pressure altimeter. So what other things were special to this drone?
Okay, I'll repeat the question. It's, I think, John, this question would probably be best answered by you. And the question is, can you tell us more about specific features of the drone that made it ideal for this work? You mentioned the pressure altimeter in the podcast. Are there other things you can tell the audience about that particular little guy? Name of Mobley. Mobley is the name of our drone, by the way.
Yeah, so this is not an off-the-shelf drone. It's a hexacopter. And it's a hexacopter because it has 6 motors and 6 propellers. And what I will say is that for us, this is just a tool for getting a camera above the whale. So, you know, it's a flying camera. So we built this and worked with engineers to build it from the camera up. So it's a platform to take very good pictures, and pictures that are associated with altitude. So the kind of things it has the 6 motors and propellers, so that it has very stable flight. Also, there's redundancy there. If something should happen to 1 or 2 of the motors, it still flies. So it's safe over water. But also that stable flight means that we can hover and we can get, the camera can take really crisp images as you've seen. The other thing with the camera is we control it from the radio control unit. So I'm actually controlling it remotely. I'm triggering it when to take pictures. The hexacopter is actually sending back a live video stream of what the camera is seeing, and Holly is actually looking at that video stream in real time, telling us what the camera is seeing, telling me how to position the hexacopter and when to take pictures. So all that's coming back from the hexacopter in real time. But I think that for real quantitative photogrammetry, there's 2 aspects of this that's important. First of all, we're not just flying a kind of off-the-shelf camera like a GoPro that's wide angle and has a round lens or a kind of curved view. It flies a camera that can take lenses that are long enough to give a flat image, and that's an image that we can measure across the full frame without any distortion at the edges. The other part of photogrammetry is precise altitude. So yeah, we have a pressure altimeter on board that records really precise altitude, and that gives us the scale, how far away we are, and therefore we can extrapolate from measurements in pixels to the size of the whale. So those are kind of features of the camera. In order to do this effectively, we have to have both reliable flight and longevity to the flight. So this hexacopter can fly up to 20 minutes and over 20 minutes. Typically, we fly less than that, around 15 minutes at sea, just to be safe and have reserve when we come back. It can fly several hundred feet away from us, which is nice because it means that our boat doesn't have to be close to the whales. So not only is the hexacopter high in the air and doesn't disturb the whales, but our boat doesn't need to be particularly close to do this. And the other thing is just reliability. This is an incredibly reliable platform. Since we first did this last year, working with the Vancouver Aquarium in Johnson Strait, we've flown 540 missions, around the world above different whale species, without incident. It's been really, really reliable, and a lot of that is due to the engineering involved in the hexacopter that allows it, for example, to know what flat and level flight is, even though we launch it from a moving boat. Perhaps, the other really important part of this is it's small and lightweight. It weighs just over 1 kilogram. So that means it's safe to hand catch and deploy, as you've seen with Holly hand catching it and deploying it on a boat. And that means we can take it on the deck of a boat, relatively small boat like the Vancouver Aquarium's research boat, the Scanner, and deploy it really efficiently when the weather's good and when the whales are there. And that's what's allowed us to photograph the entire southern resident population in just a few weeks, for example, because rather than trying to schedule expensive aircraft time and have that with weather and when the whales are present, we can just have it on the back deck of the boat and be ready to fly when the whales turn up. So there's a lot of thought and development that's gone into the hexacopter, and it's really fun to seeing it pay off now.
Thank you, John. We have a few questions coming in from the online audience. I think perhaps the first one could go to you, Holly. The question is, do whales notice the hexacopter? Do they roll and look up at it? And I think the reason I think Holly would be particularly good for answering this question is she spent a lot of the research project under a towel, as you'll see in the B-roll and the photos that we'll supply to media, so that she was sheltered from light so she could watch a monitor and actually see a live video feed of what the camera was seeing. So John and I were sitting there on the boat looking out at the whales. She was actually the one who had the bird's eye view.
The answer is no. We've never seen any response for the whales. They've never rolled over and looked up. And we actually, part of the work that we did up in Canada, we did a behavioral response study for Department of Fisheries and Oceans and flew at a number of different altitudes. And even when we were quite lower than our normal altitude of about 100 feet, we saw no response from the whales.
Thank you, Holly. Another question that came in online was hexacopter surveillance also used to monitor boaters and potential harassment of southern resident killer whales? And I think I can say in the course of this study, that wasn't our intent and our focus. And generally, the footprint of the image that we could see was large enough. You'll get a sense of that again from the pictures that will be provided to you, and probably from some of those you've already seen, to capture the whales or several whales at a time, but not large enough footprints to generally see other boats that might have been engaged in whale watching. A related question was, this one is for Lynn, how is this research helpful for management of southern resident killer whales in particular?
Sure, thank you. So as both John and Lance mentioned, we're able to link these photographs and understand the health condition of the whales in relation to other factors like salmon abundance. And what I'm really interested in is this year-to-year change and the seasonal change to see if we're able to focus in on a time and a place, part of the range of the whales where they are food limited, where lack of prey is causing a health concern. So I think that's really a key part of the study. We'll also be able to link these photographs and this information about health to other factors, reproduction of these females, or we can also look at what the contaminant levels are in those females and how they're reproducing. So lots of great information coming from the study that will help us make informed management decisions that will contribute to the recovery of the endangered southern residents.
Lance, if I could just jump in quickly and just point out that maintaining an adequate food supply is identified as a priority both in recovery plans in the U.S. and Canada. So this directly addresses data gaps and management needs that's been identified on both sides of the border.
Okay, thanks, John. Yeah, I think that's that is important, and I would say I'm seeing signs, and I think we all are, a very good cross-border collaboration in this work, not only in the research project that we're involved in, but also in the approach that NOAA and the Canadian Department of Fisheries and Oceans are taking with beginning to try to understand how these data will help inform salmon management. Another question was, were salmon more abundant? Who would like to take this question?
I think you should take it, Lance.
Okay, I can. Yeah, it certainly seemed to be this 2014 and 2015 were both quite good years for Chinook salmon in terms of abundance in our particular part of the coast, both in the area of the northern residents and the southern residents. There's some indication from fisheries, some good indication from fisheries departments in both countries that the average size of the fish was smaller, particularly in 2015, and that's interesting to us, but the actual numbers seem to be quite robust. The official numbers will be released at some point soon, but it was I think it's safe to say a good year for Chinook. The owner of Telegraph Cove Resorts, which is the small community on the northern Vancouver Island where we based for the northern resident killer whale work, has owned the place for 37 years, and he said he's never seen, the fishing was better this year than he's ever seen. And certainly from the hexacopter, we saw more instances of killer whales actually chasing and catching fish this year. There was a lot more foraging going on. It seemed to us with northern residents in 2015 as opposed to the previous year. This could change, of course, and will change. Natural fluctuation is part of the game with salmon. Also, as we know, this was a very dry year in this part of the coast. River temperatures are much warmer than usual. River flows are down. It's not a good year for. It was a good year for returning Chinook salmon. It was not going to be a good year for many salmon species, including potentially Chinook, for spawning success, for getting up the rivers to the spawning grounds, and so there's a lot of concern about that. So we've seen a good year, a couple of good years, and we're relatively good years, and we're thinking that sadly we could be looking at one or more bad years coming up soon.
And just to add sorry, go ahead, Lynn.
Yeah.
Okay, I'll just add that these whales have very large home ranges that overlap with so many different salmon runs from California up to Southeast Alaska, and so we do need some variability in the run timing, in the runs that are doing well and abundant for the whales. And so we've had a broad support for salmon recovery coast-wide, and I think this photogrammetry study will also help us focus in on some particular salmon recovery actions that can benefit not just the salmon, but also specifically help recover the southern residents and help with the northern residents as well.
Thank you.
And just to follow up, what I was going to say is that, I think one of the reasons why we're so excited about our success this year and last year is that we now have established a baseline for condition and growth in these populations that could be really important over the next few years. Is, if these whales and their salmon food are faced with, with warm river temperatures, low water in rivers, warm temperatures at sea with the El Nino, we now have a baseline at which we can evaluate whether those are and how those are having an effect on their prey and the whales. So I think that's the real success of what's coming here.
Thank you. Good points, both. Do we have any more questions from our flesh and blood audience? Linda, go ahead.
So given that killer whales are so hard to study because they're underwater, how significant, how revolutionary is it to discovering new things? Is this new technology? Repeat the question.
Yeah, the question was, given that killer whales spend most of their lives underwater and are inherently difficult to see most of the time, how revolutionary is this method for learning new things about the species? And I think you mean generally, Linda, is that correct? We've talked about the specific aims of this project. I don't know, John or Holly, you might like to take that one, having really pioneered the method.
Yeah, well, I think this new technology helps. It just gives us a view we haven't seen before. And I don't want to give the impression that the old technology doesn't work. For example, the tried and tested method of taking photos of whales, counting how many are in the populations is crucial information. We've got colleagues on the Canadian side at Fisheries and Oceans Canada that do this in northern residents, and colleagues on the US side at the Centre for Whale Research on San Juan Island that do this for southern residents. And we need that information. But what the new technology does is add resolution to that. We can now not only say how many whales there are, we can say what condition they're in. And so I think that's the context by which this new technology helps. It adds to our assessments rather than replacing traditional assessments. And the views we've got, you can just see that it allows a view of a whale we just haven't been able to obtain. And I think that it's a bit of a crude anecdote, but if you think it's only a few decades ago that to tell what condition a whale was in, it had to be on the deck of a whaling ship. Now we can tell what condition a whale is in by taking a photograph of it. And, it might be complicated new technology, but it's a really simple question.
Yeah, I think that's great. Anything to add to that, Holly?
Oh, no, I think you covered it.
Okay. Yeah, I must say, I've been been involved in killer whale research for, I hate to say how long, but over a quarter of a century. And I was amazed, really, the first time we started looking at these images from the air at how much more we could see. Looking straight down into the water, you're only looking through, you can see a lot through a few meters of water. And of course, looking at an angle from a boat, that's something you miss entirely. So I'm sure this approach will be used for lots of different kinds of studies going forward. Studies of behavior, studies of foraging, studies of sort of social affiliation, and so on. It's really very simple, as John said, conceptually. We would have been doing this 20 years ago if the technology had existed, if a tool like this had been available to us. But it's really exciting for us as biologists now. It's like having a new set of eyes. Another question that came in online was how many whales are currently present. I believe we got 3 definite, or 3 fairly certain pregnancies in southern residents and 3 likelies. John and Holly, was that your recollection?
Yeah, I think the answer is we know that some of the animals are clearly pregnant in the images, but we quite simply haven't begun the more detailed analyses. Holly's going to spend a lot of time over the next few months going through the pictures and doing quantitative measurements of their width profiles, and that will really give us a metric by which we assess whether whales are pregnant or not. So we're not in a position to say how many yet. We know some of them are clearly pregnant. You can see that in some of the photographs that are associated with our podcast, that those animals just have a different shape. And there's also links to the podcast we did last year on our work with northern residents that show the shape of pregnant whales. So, yeah, the answer is some of them, and we don't know how many yet, but watch this space, and in the next few months we'll have an answer to that. But it's not something we can immediately look at because, of course, when we go out and over a couple of weeks, we encounter whales that are in different stages of pregnancy. So some of them might be heavily pregnant, and it's obvious to just the naked eye that they have a different shape. But others may be just subtly wider as you move down the body. And so those are the subtle cues that Holly will be looking for when we do quantitative measurements. So, yeah, we don't have a definitive number on that yet, but there certainly are pregnancies out there in both populations.
And of course, one thing we don't know is how many pregnant whales actually successfully deliver calves, and that's something that this study will be very useful in determining, I think, as time goes by. Which leads me to another online question, and that is, how long will the study continue, and how is it funded? John or Holly, I don't know if you feel like we can all tackle that, maybe?
The question was, how long will the study continue? And then maybe Lance can answer how it's funded.
Well, we hope to make this a long-term project and continue as long as we can get funding. The Vancouver Aquarium has been integral in the support of the project for the past 2 years. And then NOAA has been providing funding as well, and the hexacopter is actually NOAA property. So we give our time and bring the hexacopter up, and Vancouver Aquarium, they host us on SCANA, the research vessel. And so we'll keep on going as long as we can, and we hope to add a seasonal component as well to see how the animals change throughout the year.
That's great, thank you. And we also, I should acknowledge, had a very helpful, small but very helpful grant from Seaworld Busch Gardens Foundation that helped us get the project started and in 2014 and carry it through to 2015. And so that's covered a lot of our boat and operational costs. So, as people, as scientists in many fields, I guess, we spend as much time as we can on our science, but we inevitably spend a fair bit of time trying to write grant applications and raise funding as well. And we're very appreciative of the support we have got for this project. And I think NOAA in particular deserves credit. They've been very supportive of the project in the ways that Holly mentioned. Without their impetus and the provision of this very sophisticated and reliable little helicopter, it really we wouldn't be anywhere close to where we are right now. Are there more questions from our audience in-house? Okay, just a couple more online questions. Will there be an online album of the photos? Well, I guess for short-term purposes, the photos, the press attending and online are able to obtain a small collection of photos, but very good photos. And I think you have the links for that already. We're not going to we've taken tens of thousands of images. We're not intending at this point to put them all online. Certainly, in the short term, the focus is on doing the measurements, organizing those photos, and for Holly to sit down and do the photogrammetric analysis. We won't probably release many of those before that's done. After that, I guess all bets are off. Do you have anything to add?
Yeah, just to add to Lance, there is the photographs that are shown on the podcast are available for download on the page with the podcast, the NOAA on the Line podcast page. And so as Lance said, some of those photos are there. But yeah, this year I think we collected 40,000 images from northern resident killer whales and about the same number from southern residents. So there's an awful lot of them out there, and we've got our work cut out to measure them.
Yeah, we sure do. How are we doing, Dina?
A couple of questions about UAVs, if there will be more in this project, and what other uses on the horizon.
Okay. Whoops. Sorry, Dina.
About UAVs.
Yeah, so the question is about UAVs and whether there are more studies on the horizon applying this technology. Is that right?
More used for this study.
Okay. Will we particularly have more use for this study?
What other ways can they be used?
And what other ways can UAVs be used? I don't know if John, if you'd like to take that one.
Sure. I couldn't quite hear the question, but I think it was, are we going to have other uses for UAVs? And I think the answer is yes. We've seen in the last year since our success with northern residents, we've expanded this to studies of blue whales, of grey whales off California, to studies of humpback whales off Cape Cod. So there's lots of applications of the same techniques. And in fact, one of the projects that we've begun doing with the Vancouver Aquarium is to actually photograph humpback whales in the Pacific Northwest, also to look at condition of humpback whales and compare humpback whales in different parts of the world. So there's lots of uses. As I said, it's a platform that we can now take on even small boats and use repeatedly. This is technology that really wasn't available to us more than 12 or 13 months ago, so things are proceeding relatively quickly. So there's a huge amount of information in all the images we get, and I see this being a routine part of what we're doing, and certainly our collaboration with the Vancouver Aquarium.
Thank you. Another online question was: has the blob, the blob of warm water off the coast, affected the whale diets or behavior? I think it's a good question. I wish I knew the answer. It's certainly the whales where we're working with is in coastal waters, unaffected at this point by that very large body of warm water. But certainly the fish that these whales are feeding on are passing around and through that warm water body. So it's almost certain to have some effect. The nature of that effect is something that we just don't know yet. We were very there was considerable uncertainty about how many salmon would return this year in view of that warm water condition. And as I've said, the returns for Chinook anyway seem to have been rather good. Do you have anything to add to that? I don't know, Lynn or either of your...
Sure. I'll just add that there are other ongoing studies looking at the prey and the diet of the whales. Our Northwest Fisheries Science Center colleagues have been out on the water collecting scale and tissue samples and fecal samples, so looking at killer whale poop to see what they're eating. And that's also a long-term study, and we have some different years and different salmon conditions. So as that work continues, that's something we can link to the photogrammetry and also better understand what the whales are eating and if they have enough to eat.
Yeah, I suspect we'll, as we repeat this study next year, it'll tell us a lot about how that warm blob has affected salmon and ultimately affect the whales. At the moment, we don't know.
Yeah.
Last question. What are the hopes for this population in the next 5 years?
Okay, so the question was, what are the hopes for this population over the next 5 years? And I assume we're talking about the southern resident killer whale population in that question. Lynn, it's all on your shoulders. What are the hopes?
The good news and the bad news. The bad news is that the southern residents have not been meeting the recovery goals that we set and increasing at the rate we'd like to see. Partially in response to that, southern resident killer whales have been identified by NOAA as a species in the spotlight, one of the most endangered species that we have listed under the Endangered Species Act. But the good news you heard from John, from Lance, from the podcast, is that we did have 5 new calves this year. The whales do seem in good condition. We definitely want to keep an eye on that and track that and be able to understand not just the growth, the number of whales in the population, but how healthy are those whales, especially those reproductive females, and how is their reproduction going. So I think this is a great new tool that gives me some hope that we'll be able to make some great management decisions, perhaps target some salmon recovery actions that will really help and support the whales. And we'll just hope that they keep this baby boom keeps going.
Thank you. Dina's asked me to, we're at the end of our time, to cut the questions off. Oh, and if there's any in the audience here. Yes, go ahead, please. Sure. The question was directed to John and Holly, and it was the photos. Many of the photos shown today were beautiful and had amazing depth and clarity. And so the question is, how did you feel when you first saw these photos and appreciated their quality? Well,
I can speak first, but then I'll let Holly has a different perspective, but she gets to see what the hexacopter sees in real time. So she sees all these 40,000 images we take. She sees that in real time and directs us over them. So I'll let her speak in a moment. But I'll say that last year, when we first got literally the first flight, we brought the hexacopter back, downloaded the pictures on the boat, and all 3 of us were blown away by how good those pictures were. In fact, one of the pictures that's in the podcast with a little gray carp in the middle was actually one of our first images. And we looked at it and we were just all blown away because, we realized we could do photogrammetry. We knew this because we've been working from a helicopter platform previously, but to be non-invasive from a helicopter, we had to be several hundred feet up. So now we were flying a quiet, smaller aircraft at 100 feet, effectively flying the same camera several hundred feet lower. So the image, I don't think any of us were prepared for how good the images would be and how rich in detail they are.
Yeah, no, it was really nice to see, like you said, I'm under the towel looking at the screen the whole time, but to see that the photos actually came out as well as they did, because, you know, it triggers every second and a half, and so after the end of the day and actually go through everything, it was pretty remarkable. I have a pretty special going on down there, but it's going to be really spectacular to start analyzing the images too. When we were doing the helicopter work, we generally flew between 750 and 1,000 feet, and so the whales are now going to be a lot larger in the photos, which is going to be really nice for analysis. So, they're pretty spectacular. Very pleased with them.
But by being larger in the image, it just means our measurements are that much more precise. So we know from tests with the hexacopter that we can resolve differences in size down to less than 1.4 centimeters. So that means we can look at scars and scratches on the whales. We can tell the individuals apart and match them to long-term catalogs. But the measurements that Holly will be coming out with are precise to within centimeters. So we can monitor growth to within centimeters 1 year to the next, and changes in condition 1 year to the next. And that's a function of the images being so good. And so that kind of comes back to my point earlier about the hexacopter. And what's special about it to us is it allows us to fly a camera lower.
Yeah, that's true. I would say I would answer that question in the same way that I did when I was asked it last year in some interview, I think. And that was, you know, for me, the one of the striking things that in the photos that was apparent from the very first time I saw them was that they really show how the whales are they make visual the social bonds between the whales. And you know, you think about this, you're out in a boat, you're watching a group of whales, you're in a big ocean, there's a lot of space there. And you see these huge charismatic animals show up. And when you can look at them from above, you see that they're spending most of their time swimming so close together they could touch. They don't have to do that. They can communicate over long distances. They, this is something that they want to do. It's part of their social, how they maintain social bonds. It makes them look very fragile in a way. When you see them, you know, in that kind of proximity for reassurance and contact, they cease to be these great big, you know, black and white things that can eat anything in the ocean, to being these fragile animals that we have to, you know, we really do have to care for. Thank you very much. Thank you very much, Lynn, for appearing on this. That was super helpful. John and Holly, it's been lots of fun working with you guys on this. We're all available to take questions, I guess. Thank you. Thank you very much.
I think I'll go outside with you so that some of the TV.
Okay, sure. See you guys.